So let's take a look at another example here, and I want to use both methods. I'm going to use a u substitution, and in one of them I'm going to switch back to x's and evaluate, and the other I'm going to go ahead and change my bounds and reevaluate. So right away I'm seeing that this bottom part should be u, because I have a second degree polynomial. When I take a derivative, I'm going to get a first degree polynomial. So I'm going to let u equal 1 plus 2x squared. That means du equals 4x dx, which gives me du over 4 equals x dx. Now that then brings me to the integral of 1/4 times u to the negative 1/2, because I have my u that's going to go in here, and it's 1 over the square root of u, so that's u to the negative 1/2 du. Now see, it didn't matter which process I use, whether I go back to x's or not, this u substitution part and bring me up to here is going to be exactly the same. So this first time through, I'm going to go back to x's, and then I'll just start here again and change my bounds. So let's go ahead and integrate this. This is going to be equal to u to the 1/2 divided by 1/2, which is going to be 2 over 4 times the square root of u. Obviously that's going to be like that. So this is 1/2 the square root of u. But I said u was 1 plus 2x squared. So I need 1/2 times the square root of 1 plus 2x squared. And now that I'm back to x's, I can go back and use my bounds based on x's. I'm going to evaluate this from 0 to 2, which gives me 1/2 times, at 2, it's 2 squared, which is 4 times 2 is 8, plus 1 is 9. So that's 2 times root 9, minus, at 0, just is just 1, root 1 is 1. So that's root 9 minus root 1, which is 1. Well, this is 3 minus 1, which is 2. 2 times 1/2 equals 1. So now I'm going to go back and I'm going to change my bounds. So I still have my 1/4 integral u to the negative 1/2 du, but I need to change bounds. So u of x equals 1 plus 2x squared. So u of 0, this is my lower bound, is going to be 1. My upper bound was 2. U of 2 equals 9. So my new bounds would be from 1 to 9. So what I end up with is this same antiderivative right here. It's going to be 1/2 times the square root of u. This time I don't have to go back to x's. I'm going to evaluate from 1 to 9. So that's 1/2 times the square root of 9 minus the square root of 1, which is 1. Now I'm exactly the same place I was. So this is obviously just going to be 3 minus 1 is 2 times 1/2 is, again, just 1. So both times I get the exact same solution. One of them I change bounds, one of them I change back to the variable of my original function. Two different techniques. Sometimes one is much easier than the other.